This lecture is going to be about normal reaction, which is also a very important force in solving questions on statics. And the way we are going to do normal reaction is we are going to compare it with the force that we've already done, that is tension. And we're going to see how it's similar and different to tension, and then we'll solve a problem which involves both normal reaction and tension. So I've already summarized the lecture on tension for the sake of brevity. We have a string which is attached to a mass which is hanging from a ceiling. Now the main elements are highlighted over here. First of all, we have an isolation volume. We have tension wherever we have a cut in a string. And these are the three properties. One, the force is parallel to the orientation of the string. So in this case, the string is vertical, hence the force will be vertical. Two, the force is always outward, going outwards from the isolation volume. So we know that this is the isolation volume. So the force will be going outwards, that is upwards. And the force is always positive. If the force is negative, that means the string is under compression, which is not possible. So these are the three things. To see them in more detail, just visit the lecture on tension. Now with normal reaction, let's see how we figure out what the normal reaction is. So again, just as in the case of tension, we make an isolation volume around our mass. And what we see is there is this contact between this rigid floor and this mass which we are cutting through. Hence, just like in tension, we'll have to introduce a force. So we draw the mass over here, and we draw the weight that will be acting on it, which is mg. And now we have to introduce a force on it. So the first question that is we have to ask is, what is the orientation of the force? So in the string, the force is parallel to the orientation of the string. In normal reaction, the force is perpendicular to surface. So in this case, our surface is horizontal, hence the orientation of the force is vertical. Next, what direction is the force in? So in the case of strings, the force is outwards of the isolation volume. In the case of normal reaction, the force is inwards of the isolation volume. So since this is the isolation volume, we'll be going from outside to inside. So in this case, since the force is at this interface, the force will be going is an upward force. So now we know that it is an upward force. So we can finally say that the force is vertical and that it points upwards. So N. So let me just write the second rule. Going into isolation volume. And the third rule, now both of these rules are actually opposite of what they are in the tension and strings, but the third rule is the same, that is the force is always positive. So always positive. So how do we determine that over here? We do a simple force balance. What we can see is the downward force is mg, upward force is n. So n minus mg is equal to 0, which gives us that n is equal to mg. Hence, normal reaction in this case is positive. So we have a valid normal reaction. Now, just if you need to just pause this screen and go through all of these rules, then we'll do the next question.